This time we are going to talk about the standard matrix for a composition of a linear transformation. The composition is described in this manner. This is the first composition of our linear transformations defined by t sub 1 and t sub 2. And this is another one where we interchange them. So let's just denote it with t prime. By the way, before we start, we can rewrite this transformation, this operation as in this form. Linear transformation of V, just like your algebraic composition. This also can be written as this. But anyway, we are not going to dig deeper on this, because what we need to do here is the standard matrix for a composition of a linear transformation. The composition, the standard matrix of a composition, let's say the first form here, is equal to a certain matrix A, which is the product of A sub 2 and A sub 1 matrices. On the other hand, your A prime is just the product of your A sub 1 and A sub 2 matrices. Okay? However, where do we get our A sub 1 and A sub 2 matrices? A sub 1 is the matrix form of the coefficients of this transformation. So for A sub 1 here, we are going to write the coefficients. Of course, x would be on the first column and y would be on the second column. Using this first entry here, so you have 1x minus 2y. Okay, that's how we solve for, that's how we use the coefficients. The second entry, you have 2x, that will be for your second column, plus 3y. Okay, that is for your A sub 1 matrix. A sub 2 matrix will be taken from the second linear transformation. So A sub 2, the first entry is 2x, and since there's no y, that's simply 0. And you have your x, or x, 1x minus 1y, that's negative 1. Okay, so these are now the matrices represented by the linear transformation. And then the standard matrix for the composition would be the product. So starting with this, the standard matrix for the composition of the linear transformation T, described as the composition of T sub 2 and T sub 1. The product of A sub 2, which is 2, 0, 1, negative 1, and A sub 1 being 1, negative 2, 2, and then 3. So simply multiply these two matrices, and since this is a 2 by 2 matrix as well as this, so the product is defined. So the product will go on like this. 2 times 1 is 2. 0 times 2 is 0. 2 plus 0, that's 2. Next, 2 times negative 2 is negative 4. 0 times 3 is 0. So negative 4 plus 0, that's negative 4. Next row, 1 times 1 is 1. Negative 1 times 2 is negative 2. 1 plus negative 2, negative 1. And then finally, 1 times negative 2 is negative 2. Negative 1 times 3 is negative 5. Negative 3, so negative 2 plus negative 3 is negative 5. This is the standard matrix of the first composition. Now for the second composition, which is T prime, represented by the interchanging of the transformations, we also have here the interchanging of our matrices. So A prime is the product of A sub 1, which is 1, negative 2, 2, and 3, to be multiplied with 2, 0, 1, and then negative 1. So simply multiply again, that's 2 by 2, 2 by 2, so the product is defined. 1 times 2 is 2, negative 2 times 1 is negative 2, 2 plus negative 2, 0. 1 times 0 is 0, negative 2 times negative 1 is positive 2, 0 plus 2, 2. 2 times 2 is 4, 3 times 1 is 7, 3 times 1 is 3, 4 plus 3 is 7. 2 times 0 is 0, 3 times negative 1 is negative 3, 0 plus negative 3, negative 3. This is then the standard matrix for the second composition of linear transformation, where it's T sub 1 and then T sub 2 then. So this is how we show the standard matrix for a composition of a linear transformation. But of course, always start with this correctly before substituting to our operations. Thank you very much for watching.